Mass can be defined as the amount of matter in an object. Weight is the force acting on that matter or that object. As with a normal force, we know that F equals m times A. Well, weight force is the force that acts on objects in the Earth's magnetic field, gravitational field. It's a similar formula, but it's the mass of an object in that field times the acceleration due to gravity. So the weight of an object in the Earth's magnetic field is W equals m times g. So an object put into the Earth's magnetic gravitational field, and we can represent the Earth's gravitational field like this, with field lines, such that any object with mass that's put into that field will experience that force, and it's a weight force. This weight force will depend on g. So a larger planet with greater mass and greater radius will have more weight force acting on objects around it. So objects placed in the Earth's gravitational field all experience that force. Satellites experience that force, and it's the force due to gravity. The satellite might be moving and changing direction, but that's the force that causes it, the change in direction. Objects, because of this gravitational force. Example where an object may be between two other objects, and it would feel a force equal from both of those objects if they're identical. The mass of an object changes as you move. The mass of an object does not change. The mass of an object is constant, no matter where you put it in the solar system or in the universe, ignoring the effects of gravitation inside black holes at this point. So mass is independent of location. Weight is dependent on the location of the object. And that's because it depends on not only the mass but the gravitational field, the gravitational acceleration, or the force acting on objects. Weight force is measured in newtons always. Make sure you put the units. Gravitational acceleration is measured in meters per second squared. And on Earth it's 9.80 approximately. Mass is always in kilograms. See, previously we drew these fields. A field is basically any area of influence. So this, say the Earth has an area of influence of all the objects around it, any objects put in its gravitational field. So just a quick rundown on gravitation, weight and mass. Weight and gravitational force are often equated together, that is, equal. Weight is the force an object feels in a magnetic field, gravitational field. The gravitational force is the same force. A force attracted an object feels, or an object is attracted with by another object. mg in this case. In this one, as we've seen in the past, g, the gravitational constant, times m1 times m2, divided by the distance between the objects. Often you'll see and in the HSC, you'll see air. Okay, we can let these equal each other because they're both the same thing in the case of being in the Earth's magnetic field, gravitational field. So here we have mg equals this and this are equal g m1. This one can be m1, m2, and r squared. We see g equals g m2 on r squared, where this is the mass of the planet, or the central mass. This one here is the radius, or the height above the planet, or the radius of the planet in the case of when it's on the surface. The distance between objects, between centre of masses, as we've seen. This formula here we can use to work out the gravity, the gravitational acceleration on other planets. An example would be Jupiter, which has a larger mass. It also has a larger radius. Jupiter has a gravity of approximately 24.5 compared to the Earth's 9.8. So you can see Jupiter and gravitational acceleration on Earth, 9.8.